welcome to class today. Today we have a topic before us, which is periodic table. Now, what is a periodic table? Periodic table is a chart that contains all the elements. And we're told in our previous class that we have 109 elements, of which 90 of them are naturally occurring and the others are prepared in the laboratory. Now, a table has been given to us for us to be able to organize these elements in that particular table, which is called the periodic table. And then the model periodic table states that the properties of an element are the periodic function of the atomic number. And what are these atomic number? We're told that if we have elements, elements have their different symbols. We learned in SS1 elements from 20 elements, and then some above we have the 20 elements, and we have various elements and their symbols. Is it okay? And then in the elements we have the mass number and the atomic number. And what is the mass number? Let's say, for example, we have let me use oxygen. Oxygen is the atomic number of oxygen is what? Is 8. And then we have the mass number. This is called the atomic number. This is atomic number, and this is called the mass number. Is it okay? And we're told that the atomic number is also the number of proton in an atom. Is it okay? We have the proton, neutron, and electron in an atom. Therefore, the number of proton is also the number of atomic number. That is, atomic number is also equal to the number of what? Of proton, and also numbers of electron. Is it okay? But electron can change in the sense that when it receives an electron, the number of electron, the one that is giving tends to reduce, and the one that is receiving tends to what? To increase. As the acceptor, and the one that is giving is called the donor. Is it okay? And this is called the mass number. And the mass number, we know very well that the mass number is equal to the number of proton and neutron. Is it okay? So that is that. So the elements are arranged in the periodic table according to their their atomic number. Is it okay? Now, this is how the periodic table is. We can just use a little sketch to draw the periodic table. This is somehow, let's take this as the periodic table. Is it okay? Now, this periodic table, the elements are arranged according to groups and periods. Now, how do we know elements in group 1, group 2, period 1, period 2, and so forth? Now, we have the elements that are arranged this way. Elements are arranged this way, this way, this way, this way, and this way. Is it okay? Elements like this is called a vertical. They are arranged in groups, and the ones like this are called the period, arranged in horizontally. Is it okay? Now, when we talk about groups, how do we know elements in group 1, group 2, group 3? We're taught electronic configuration, where we're told that the first share is called the K share, which is K share. We have the L share, the M share, and all the rest. And we're told that the K share contains 2 electrons, which is called the duplet. And then after the 2, the L share contains 8 electron, which is called the octet. Is it okay? So now, if you look at this, the first one contains 2 electrons, the next one contains, so these numbers of electrons will determine where the group is, and that number is called the electron is called the valence electron. Is it okay? Ew. It's called the valence electron. Now, what do we have here? This is group. What will determine an element that will belong to a particular group? Let's take chlorine, for example. Chlorine is 17. Chlorine is 17. If I have to do the electronic configuration of chlorine, it's going to be what? 2, 8, 7. Now, the valence electron here is what? Is 7. So therefore, chlorine will belong to group 7 of the of the periodic table, which is called the halogen, because each of these group have name. Is it okay? Each of the group has name. Like we have the alkaline earth metals, alkaline metals, and all the rest. We have the noble gases and the rest. Okay, so that will determine the group. Let's say hydrogen. Hydrogen have just 1 electron. Hydrogen belongs to what? To group 1, because it just have 1 valence electron. Is it okay? Now let's talk about calcium. Calcium is 20. Calcium is 20, which is what? 2, 8, 8, 2. Now, what's the valence electron here? The valence electron is what? 2. So therefore, calcium belongs to what? Group 2 of the periodic table. Let's take aluminium. Aluminium is what? It's 13, which is 2, 8, 3. Now, if you look at the valence electron here, is what? It's 3. So therefore, aluminium belongs to what? Group 3 of the periodic table. Is it okay? Now, that is what will determine the various what groups a particular element will belong to. Now, let's talk about the period. The period has to do with the numbers of shares a particular element has. Let's say, for example, oxygen has just one share, K share. So, because just one, it belongs to period 1. So this is period because the group, sorry, I forgot to tell you, the group is from 1 to what? 0 or 8. Is it okay? The same thing with the period 1 to 7. Is it okay? Now, the next one is, let's say we have calcium. Calcium, how many shares does calcium has? It has K, L, M, N. You can see 1, 2, 3, 4. So therefore, it belongs to what? Period 4. Let's take aluminium. We said aluminium is what? 13, which is 2, 8, 3. 1, 2, 3. It has 3 shares. That is K, L, M. Therefore, it belongs to what? Group 3 of belong to period 3. Okay, they can give you a particular element. They'll tell you what group and what period does this particular element belong to. So let's take sodium. Sodium, we said sodium is 11. So now it's 2, 8, 1. Now, what group does sodium belongs to? Sodium belongs to group 1 because it has only one valence electron at the outermost shell. Is it okay? Now, which period does sodium belongs to? It belongs to period 3 because it has K, L, M. Are you getting it now? So that is how you know the period and the group a particular element belongs to. Now, the next thing we'll be talking about is that these periodic tables are divided into metals, metalloids, and non-metals. Is it okay? Metalloids are those elements that have both the properties of metal and non-metal. It's just like using, example, a transgender. A transgender, when you see a transgender, you'll be confused whether it's a boy or a girl. Is it okay? Because they both have the properties of a boy and that of a girl. So that is how metalloids are. They're also called semi-metals. Is it okay? And then, where do we find them in the periodic table? Now, there's a diagonal line here. So all the elements that fall within this range are called the metalloids. These are called the metalloids. From here down, they are called the non-metals. And everything this way are called the words, the metals. That's how the periodic table is being shaped. And then also in the periodic table we have this corner. You see this place here. If you notice, we have 1, 2, then you see 3, 4, 5, 6, 7. You notice that they didn't put this element here. These elements are called the transition elements in the periodic table. Are you getting that? This part you're seeing are called the transition element. Then we also have a smaller one here. There are elements here that if you put them in the periodic table will be too long. Are you getting it now? So they have to put them here. So if you check the periodic table, you see that there's going to be a change in numbers when you get to this element. And these ones are called, the one up is called a lanthanide, lanthanides. And these are called the what? The artanide. These are called the inner transition what? Elements. Is it okay? So that is how the periodic table is being what? Arranged. I hope you understand. Thank you very much.